Guten Abend, mein Name ist Tagir Valeev und ich mache eine Vorlesung heute, aber ich spreche nicht so gut Deutsch, deswegen meine Vorlesung ist auf Englisch. Ehrlich gesagt spreche ich auch nicht so gut Englisch, aber hoffentlich ist es besser. So, my talk is named Have you ever considered just not writing bugs? And the title is inspired by this tweet, and it looks like a good idea. If you don't make bugs, things will be much easier. We don't need to spend time in debugger. We don't need to test much more. Users will be happy. Our revenues will be growing. So it looks like we should try. While it's probably not very possible, but we can do something at least to reduce amount of bugs. So I will try to speak about this today. And a few words about me. I am programming for a very long time, and last like 15 years I'm programming Java. About 10 years ago, I discovered static analysis. It was find bugs tool. Anybody knows find bugs? Yes, yes, great. And now it's named spot bugs, like it was a fork. So it was like a revelation for me. I was really astonished that the tool can find real bugs in my software without even running it. Just run the tool and it finds real problems. But after using it for a while, I noticed that it's like not ideal. It has false positives, false negatives. So I started to enhance it. I actually contributed to find bugs for some time. And after that, I joined JetBrains, which is a company behind IntelliJ IDE. So now I basically do the same, but for money. Yes, I'm doing different stuff, but pretty much is enhancing static analyzer, which is built into our IDE. Among other things, I'm OpenJDK committer and I'm Java champion, and also, as you have seen, I wrote a book about Java mistakes. So you can get it from Munich website, or you can get it from Amazon if you like. And if you get it from Munich website, there is a promotion code provided by Munich, especially for this meetup, and you can get quite a big discount. And actually, I guess it works not only for my book, but for any book on Munich website. So. Pay attention. Okay, enough with self-promotion. Let's start with content. There are different kinds of bugs, and there are like huge and complex bugs, which it's really exciting to read blog posts about them. Like you have a huge system with several components, and one component sends slightly incorrect request to another component and it understands it correctly but doesn't fail, but instead produces wrong result, and it goes to the third component and things are going even worse and so on. So it's really exciting stories, but it's not so applicable to your day-to-day work, like because your story will be completely different. But there are also many tiny and local bugs, like one line of code is incorrect, and if you will fix it, everything will be okay. But even if bug is tiny, the consequences could be as disastrous, because many things can go wrong, even if you have typo of one character. But the good thing about such bugs is that they are repeatable, so they happen over and over, and they could be classified. And that's what I basically did when I wrote my book. I classified some repeatable bugs, so if you read about them before, you'll be prepared and probably not make such a bug in your program. And after I wrote a book, I started to notice problems in our code base or on code reviews. So sometimes I leave comments on code reviews like this, like you are doing basically mistake number 70 from my book. Hopefully my colleagues don't hate me yet for this, but this really happens. Okay, so before we speak about individual samples, let's think about how to avoid bugs in general. Which kind of techniques you can employ to avoid bugs during programming? Any ideas? Yes?
Don't repeat yourself.
Don't repeat yourself. Good idea. Yes, static analysis. Static analysis is a great technique. Any other ideas?
Testing.
Yes, testing. Yeah, testing really great. Testing, like, it really helps. So no
Pair
problem.
programming.
Sorry?
Pair programming.
Yes, pair programming, exactly. Pair programming really helps because other person may find the bug which you don't see. It really helps. Yes?
One very simple one that I noticed made a huge difference was when you copy paste something, just look 2 times before you do anything else at the part that you pasted.
Yes, yes, exactly.
It's not the same and doesn't stay the same.
Yes, in fact, bugs really love repetitions. There are many bugs lurking in repeating parts of code. So if you copy paste, be extra careful and try, yes, not to repeat yourself. If it's possible to avoid copy pasting, try to avoid it. Sure. Yes, you actually named many items from this slide. Probably there are not all items, but there is also code review, which kind of related to pair programming. And we have one new shiny approach called AI. AI can probably help, but it's really something new, so probably we don't yet understand how to use it efficiently, but at least we can already try. But there is a bad news, and bad news is that there is no silver bullet. Like there is no single approach that can help you to eliminate all the bugs. Like some people may say, okay, I don't need code review, I don't need static analysis, I will write tests, I'm using test-driven development, my code is 100% covered with tests, so I have no bugs in my code base. This doesn't work. And I actually tried. I have my own pet project called StreamX, which is enhancement of Java Stream API. It's like quite a small library, it's open source, you can try it. And I really covered it at 100, not 100, but 99 dot something more than 99.5% is coverage. And at some point, writing tests takes much more time than writing the actual code. So when you approach to 100%, you spend more and more time on writing tests, and it may simply become too inefficient. You will not write actual code at all if you will be too obsessed with tests. And another thing is that even if you have 100% coverage, it doesn't mean you don't have bugs. We will see an example today. Other people may say, okay, I will rely on static analysis, and they may even improve static analyzer, like write plugins to their static analyzer. It's quite possible. You can create new inspections or new detectors which are specific to your project. So you can again invest a lot of effort to static analysis, but still at some point it will not help you to catch more bugs because static analysis also has its limitations. Or you may say, okay, I rely on code review completely, and I like every change will be reviewed by 5 people, for example, and it's again a lot of effort, but at some point it will go to plateau, so you will not be able to find more bugs. But there is a good news, and it's Swiss cheese model. It was initially described by James Reason in 1990, and it was like in context of aviational engineering and medical equipment and so on. So the idea is that you should not try to create single ideal bulletproof layer of security on your system because it's nearly impossible in many cases. But instead, you should create several different layers, And in this case, if the first layer doesn't catch the problem, then second layer, which is designed in different way, it catches totally different problems, then it's likely that the second layer will catch. And after that, you can put third layer and so on. So I think that this approach is much more efficient in software development. So instead of putting all the stakes on single layer, you should distribute your time resources to several layers, like static analysis, code review, unit testing, maybe more. And those layers are really designed to catch different kinds of mistakes. So in this case, you will catch much more. But some mistakes will still make their way to production. So it's like endless struggle. You cannot win here. Okay, so let's try to speak about individual problems. And my first example is this quite simple method. By the way, I guess all or almost all examples from this presentation are actually based on the real code. So it's not like I made up the things. Here we have a simple method which accepts a string and amount of indentation, and we want to prepend it with spaces. But we want also to accept negative indentation and tolerate it. In this case, we probably don't want to prepend anything. So, and somebody said to the author of this code that if you create string builder, it's a good idea to pre-compute capacity, because in this case, you will pre-allocate the internal buffer of exactly necessary size, and you won't need to reallocate it, and this will like optimize your code, make it faster. By the way, anybody thinks that this is a good idea to specify initial capacity for string builder? It depends, yes, it depends. Okay. But yes, some people still think that yes, we should do it always. It looks like there are no such people in this room. That's good. Okay, so you can see that capacity is computed like we take length of the string and we add indent, but if it's negative, we simply add 0. So what's the problem? You can probably already see it. Yes, the problem is with operator precedence, because ternary operator has very low precedence, and in fact we compute first string.length plus indent and then compare the result to 0. So the resulting capacity will be basically either 0 or indent. But in both cases, it's unlikely what we actually want. But sometimes this method actually works, because even if capacity is wrong, then string builder will work. It will just work not so optimal. So if indent is non-negative, then capacity will be equal to indent. It will work. And if indent is negative and very negative, like very low,
less than strength.
Less than length of the string, less than negated length of the string, then in this case our condition will be less than 0, so initial capacity will be 0, and string builder accepts 0 as initial capacity. It will just reallocate first time you append something. But if the indent is negative but not negative enough, then capacity will become negative and string builder constructor will fail. So you will get a mistake like illegal argument exception, I guess, from string builder constructor. By the way, I said that AI may help us to find bugs. Why not? Let's try it. Well, it's not like AI promotional talk or something, so I will just try exactly one AI implementation, which is AI assistant built in IntelliJ IDEA. And if you have subscription to this plugin, you can just select some method, for example, and in the floating toolbar you can select find problems from this AI menu. And it finds like 3 problems. The first one, it says that you are not handling null, and you should probably handle null input as an empty string, which I don't agree with because usually, well, it depends on your code style in your project, but usually it's responsibility of the caller not to supply null, and if the null is supplied, it's actually better to fail with null pointer exception because there is probably a mistake somewhere at the call side. So I don't buy this. The second is about negative indent handling, and it says that we should not handle negative indents, we should throw an exception in this case. But I actually wanted the opposite, so I don't buy this either. And the third one, it says that capacity could be incorrect in some cases. Its reasoning is not entirely true, but at least it gives a hint that there is a problem in capacity calculation. So probably from reading this, you can find a bug. But to find this, you have to go through previous items. So, and at the very beginning, you should select the method. So you should suspect that there are problems in this method. But probably it may help. So, how to fix it, and what's actually wrong? What's this wrong actually? The naive answer would be like, okay, we just need to learn precedence table in Java, or if you don't want to learn, we just need to put parentheses everywhere, and the problem will be solved. But it's like not so deep problem. So if I were AI and somebody would ask me what's the problem in this code, I would have actually 4 items, and they are listed here. The first item is that initial capacity is not easily testable. So in this case, we were actually lucky because for some inputs, this method actually fails. But it could be not the case if we made a mistake in capacity computation. It could be always wrong, but we will never notice this because it will just work. Just with incorrect capacity, it will be less performant. And it's quite unclear how to write a unit test in this case, like how to check that this method actually computes initial capacity correctly. So the initial capacity matches the actual amount of characters written into string builder. Here, asserts can come to the rescue, and you can use assert statement right inside this method because you have like invariant that the length at the end should be equal to the capacity at the beginning. If it's wrong, then we should fail. And if we add this assertion statement, then the problem will be easily detectable, like almost with any input, this method will fail and you will immediately find the bug. So if you have like 2 values which should be equal, why not to write an assert to like encode this invariant? And this also actually documents your code because the reader will see that the intention is to make those 2 values equal. Another problem is manual algorithm implementation. We have very short algorithm here, finding the maximal value between indent and 0. And why the algorithm is very simple, it's implemented manually for no reason, because it would be better to write this way. And magically, when you write it this way, the problem is fixed, because it's much harder to screw with operator precedence when you call methods. This is a trap many programmers fell into, because programmers say, okay, I know this algorithm, I will just implement it inline. It's very simple. Why should I call a library method? Some people may even think that, okay, calling method could be like less performant, which is totally wrong, because in this case, even simple JIT compiler will easily inline this call, so it will be basically the same performance. Here we actually encode the intent. We say that we don't want to compare something, we don't want to write conditions, we want a maximal value. So the code becomes more readable, and as you can see, it becomes less buggy. The third problem, which is actually connected to the first one, is action at a distance. Like our code is fragile because if we want to change it, we have to change it in several places, here in 2 places. Like imagine that we later need to automatically add a line break at the end of the string, always And in this case, we can say append line break, but we should also change the initial capacity. We should also add +1 there. And if we don't do this, then again, our capacity will be totally incorrect. It will be probably the worst capacity because we will always allocate one character less. So it will be always reallocated. And we will not notice this unless we add a short statement or something like this. So think about this when you design your own API. Like if to change something in your code, you need to change in two places because changing in one place is not enough. And the program will not protect you from changing in one place only. Then probably your API is not that good. You probably should think how to make it like more robust, that you should change only one place to get the desired result. And final item is, of course, premature optimization. Because why we even decided that specifying capacity will improve our code? Well, because like it's wisdom of ancient people. But there are usually two cases. One case is that nobody cares about performance of this method, and it's the most common case because if you profile your program, this method is never on the hot path. It's executed only rarely, and even if it's twice as slow, nobody cares actually because it doesn't affect the performance of your program in general. And another case is that this method is actually a hot method. It's called very often, it appears in your profile, so it must be optimized. And in this case, if it must be optimized, then why stopping here? You should optimize it even better. And the first idea is very simple, like if indent is non-positive, then let's just return original string. Why should we even allocate string builder, copy something there, then copy back to a new string, allocate something? We should not do this. And after that, the original bug is actually magically fixed as well, because we don't need our conditional operator anymore. But there is even better way. You can write this way. So you don't need string builder at all. You don't need loop. The code is much simpler. Well, some people may think, okay, but string builder is probably more performant. Like here, we allocate the intermediate string, which consists only of spaces. And with string builder, you don't allocate this intermediate string. So probably this code is not so good.
I think compiler will replace it with string builder.
No, in modern Java, no string builder will be created at all after undefined string concatenation, which was delivered in Java 9. Actually, concatenation will be done directly on the target array, so it will be quite fast. And if we test, we can test with no capacity at all. So no capacity is specified and capacity is specified. And as you can see, capacity improves the performance not always. Sometimes it makes the code actually working more because you have to compute the capacity. But the difference is very tiny. You have good improvement only if you have like very big indent, like 100, and very, very long string. It was also about 100 character, like very, 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 very long string. So in this case, you can get like probably 50 or 30% improvement. But in other cases, the improvement is marginal. And by the way, if you have like Chinese string, like ni hao, in this case, the performance is much worse. Like even if string is short, but you have very long indent, you can see that performance is much worse. And, you can think why it happens. And if you know, you can say me after the lecture. But if we use string repeat, it will be always faster with any input, and it will be significantly faster. So if you actually have a performance bottleneck, just try different solutions and profile them, not just specify capacity because people say that it will be better. And in this case, the code becomes actually much better. So you don't have action at a distance. You don't have any kind of algorithms. You can add plus line break and it will work just as fine. It's much shorter and it's much more readable and it's much faster. So win-win. Another very similar sample, I will not stay here for too long time. It's initial capacity of array list. Again, people wanted to optimize something and again, it was screwed up. But I like the sample because it's even more amusing because yes, here we have similar problem, but we wanted to have mathematical addition input size plus 0 or 1, but instead we have string concatenation here. Input.size is converted to string, like 5 in quotes. Then we concatenate new item. If new item is null, then we concatenate string null, so it will be like 5 null. And it's obviously never equal to null, so this condition is always false, and we always have 1 as initial capacity, which is unlikely what you wanted to specify it. And likely it's much worse than the default implementation, so it would be better not to specify anything. Luckily, in this case, static analyzers help you because it's quite easy to deduct statically that this condition is always false, so you are probably doing something wrong. Okay, let's move to something different. Here's another simple static method, and the idea is to generate a unique identifier. Like we have ID candidate and we have some used IDs. So if this ID is not used, we will just return it. But if it's already used, we have to invent something new, like adding some kind of suffix like _1 or something like this, and return it. So as it was mentioned here, writing tests is a good idea. So let's write tests, but we are too lazy. So how to solve this? Of course, ask AI, because AI can write tests for you. It's a good idea. And you can also select method and tap generate unit tests. Well, it will not always work nicely because you may have like a lot of dependencies in your project. It could be very complex method. Of course, AI cannot test anything. But in this case, it seems that it works very good. So it's just plain result I've got without any editing. It wrote 2 tests, and as you can see, the first test is about testing that ID is not used yet, and we assert that the method returns the same ID as we provided. And the second test tests that ID is used yet, is already used, and we assert that it generated some new ID, which actually makes sense. So this test set looks quite good. And I launch it, it's successful, all tests are green, but probably we don't have enough coverage. Let's test. I checked with coverage and we have 100% coverage. So we have 100 line coverage and even 100 branch coverage. You may know that covering all the branches is usually harder, but here we have while condition, which can be true or can be false, and we actually covered both cases, like when ID is used and when ID is not used, both tests are covered both cases. So it looks like we're fine. We can commit, push, and move to the next task. But unfortunately not, because I can write another test like this. And if you launch it, you will get this. The method will never finish, because if you look again, you can easily find the problem. Yes, I is never changed. I is always 1. So when we first time visit the loop, we change ID to ID underscore 1. But when we visit it the second time, we again change it to ID underscore 1 and so on. It's always ID underscore 1. It's never ID underscore 2. So when I first discovered such a bug, I tried to think how to generalize the problem to find like a bigger class of problems like this. And I came with concept of idempotent loop body, which basically means that the body of your loop naturally changes the state of your program, because otherwise, why would you need this loop? But it changes the state of your program only once. Like if you execute the body of your loop 2, 3, 4 times, it doesn't change the state of your program anymore. And I discovered that simple cases like this could be covered by static analysis. So all of loops with idempotent loop body are wrong, because there are basically 3 cases. First case is condition is false initially, and in this case the loop is not executed at all. The second case is condition is true initially, but the body makes it false. And in this case the loop is executed only once, and everything is fine. But there is a third case when condition is true initially and the body doesn't change it. And in this case the loop becomes infinite, because as we said, if body doesn't change the condition for the first time, it will not change it on the second iteration, on the third iteration, and so on. And the unpleasant thing is that sometimes people test only first and second case, as we have seen. Even AI does this, not only people. So, and the third case becomes not tested. But the nature of loops is to be executed more than once, at least sometimes. Because if you write a loop which should be executed at most once, why would you need a loop at all? You probably need an if statement or something, but not the loop. And if you have a loop, it's better to test how it behaves when it's executed more than once. So simple cases actually can be detected by IntelliJ IDEA, and this code is highlighted with idempotent loop body inspection message. But in more complex cases, especially if you call methods inside while body, it becomes more problematic, because it becomes quite difficult for static analyzer to prove whether the loop body is idempotent or not. Sometimes it can still do it even with method calls, but of course not always. And the thing I would like to point out again is that if you have a loop, your tests should test how it behaves on at least two iterations or more. Unfortunately, like conventional coverage tools like JUG doesn't show you out of the box that your loop was tested only with one iteration. It happily shows like you have 100% coverage, and you don't pay attention to this problem. So you should pay attention by yourself. Let's speak about something very simple. This print inclusive, basically a textbook sample to print all numbers starting from and ending with 2 inclusive. So what could be wrong here? Let's ask AI, why not? And it found 3 problems. The first about invalid range, like what will happen if from is bigger than 2? We don't handle it. In this case, we will print nothing, but probably we intend to do something else. Okay, probably valid. And second and third are basically about the same problem, is that it's possible to specify like very big interval, and in this case we will print probably billions of numbers. Probably we don't want to print billions of numbers to the console. So okay, let's address those problems, just make our method bulletproof. We will throw exception if from is bigger than 2, and we will also throw exception if difference is too big, because we don't want to print a lot of stuff. Okay, let's ask AI again. Is it better now? And now it found 6 problems. And it actually started, I would say, hallucinating. The first problem, it says that condition 2 minus from less than 0 is unnecessary, which is actually not true, because you can specify from is minus 2 billions, 2 is plus 2 billions, and in this case, from bigger than 2 is false, and 2 minus from will overflow. You will get negative result, which obviously less than 100 or less than 1000. So you will not be protected and you will actually print 4 billions of numbers. So it's actually wrong. Second one is just crazy. It says that you don't have any null checks. But I don't work with any objects at all. There are only primitive values. It says that, yes, you don't use any objects, but if you use it in future, you will probably need null checks. So, okay. The third one is the most reasonable here. It says that our exception messages are not too detailed. Okay. The fourth one, it says that our method is static, which is not so object-oriented. Well, okay. It would be, of course, better if I created print inclusive builder manager, and print inclusive builder manager factory. In this case, we would get very object-oriented program. Yes, exactly. And the fifth problem was about something outside of this sample. Because it was just a sample, it was not part of production code. It says that something is unused. And the last item is about we are throwing unchecked exceptions. And it says that unchecked exceptions is bad. I would not think that AI will be a proponent of checked exceptions in Java. But okay. But it also says that those issues are not necessarily problems. So it tried hard. But still, the code has a problem. It's possible to break it. And I will show how. You can call it with such arguments, supplying 2 as max value and from a little bit less. And if you do this, you will get unlimited amount of numbers, so your loop will be endless. That's because nothing can be bigger than max value, so I less or equal than 2 will be always true. And I++ will overflow naturally, and you will continue with negative numbers, and the loop will never stop. So some people may say, okay, it doesn't happen in practice, who works with such big numbers, but it's really dangerous, because if your corner case is very rare, when it strikes you, it strikes very hard. So it's possible to fix it in different ways. One way, which is like the simplest probably, is to add this seemingly useless condition I is bigger or equal to from, because when we overflow, this condition will protect us and we will exit immediately. And it actually happened to me in IntelliJ IDEA code base. Somewhere inside Java static analyzer, I had this problem actually. I wrote such kind of loop, and it was actually protected against big ranges, against invalid inputs, but it wasn't protected against this overflow problem. So, and when we deployed it, luckily it was only early access version, not production version of our IDE. It appeared that when you open quite specific Java file in editor, then the static analyzer will stuck in endless loop. So your CPU will be burning and your IDE will be freezing. And yes, we discovered and fixed it pretty fast, but yes, the problem happens. And if you don't think about it, you think that your inputs are never max value, it may still happen, and even if it doesn't happen like randomly, it may happen on purpose, because some of your users may actually want to break your program, and they may actually use inputs like max value if the input is coming from untrusted source. And in my case, it was quite uncommon Java file, but it was not specially crafted Java file. It was a real Java file from some people's project. So nobody actually wanted to break my analyzer. Just was broken. Yes. But again, is it really a solution to add this protection condition? Is a better solution? Well, probably yes. One better solution is to use Stream API. And you can even do this automatically with our code. You can press Alt-Enter in IDE and convert it to inStream.range closed from 2 dot for each. And this is again the same problem. We have manual algorithm implementation. The algorithm again very simple. Like we want to iterate all numbers starting from, ending with 2 inclusive. And we say, okay, we will write the for loop, but we actually manually implementing algorithm, and you see that there is a bug in this implementation, and this like very canonical idiomatic implementation, it's actually buggy because you are not protected against overflow. And if you use a library method, range closed, you make your program declarative. You say like, I want range of numbers. I don't care how actually you will iterate them. I just want range of numbers. And naturally, it's not broken because it's library, it's well tested, all corner cases are covered there, so you will have actually ending with max value without any overflow. But there are problems with Stream API. Not every loop could be converted to Stream API. You know, you may probably want to exit in the middle or probably want to throw checked exception because AI suggested you to do so. Another problem is that streams still have performance overhead, especially when you're working with primitives. So when you're working with primitives, it's mostly like visible and it could be undesirable. So in my case, I decided that it's undesirable to convert to streams because this part of analysis should be fast. There is another solution. You can convert to Kotlin. And again, you can do it in single keystroke in IDE, Ctrl-Alt-Shift-K, and in this case, your program changes to Kotlin, and the bug is magically fixed. I think that the authors of this converter didn't even know that they can actually automatically fix the bugs in your program, but they can. And in this case, again, we have declarative code, because Kotlin has actually the construct to express the intention to iterate the range. So you don't need to express your algorithm. And it compiles it to quite optimal bytecode, but it actually adds this protection condition inside. Because, of course, it's done in compiler. Compiler is well tested. They think about all corner cases, and they should think about it only once. And you don't have to think about it anymore. So it's great. Unfortunately, there are no ranges as first-class citizens in Java yet. Hopefully, this will happen someday in future, but we are not there. So, my idea is that for every useful and repeating task, even if it's very small, even if it's one line, you should have either a language construct or a library method. So, if you have this task like iterate of closed range of numbers, then if it's possible, it's better to use dedicated construct because it's likely well tested and it's declarative. You declare the intent, not like describe how to do things. There is another sample which is kind of connected, clamping values. It's a simple piece of code where we want to print progress in %, but we want to tolerate too big or too small values, like if input is negative, we will print 0. If input is positive, if very big, we will print 100. So why not? This happens. Some people may prefer writing in a more compact way. It's not so bad, but still not optimal because you have several conditions. You repeat all boundaries twice. You repeat 100 twice. You repeat 0 twice. You repeat your input % even 3 times. So, not very nice code. But at some point, somebody noticed like, hey, it's actually computation of maximal and minimal values in a row. So why not just collapse it like it was in the first sample, and we can use sequence of max and min computation. And it's more compact. We don't repeat boundaries. Well, sorry?
Yeah, I think you confused min and max.
Yes, exactly. Yeah, it's wrong. Yes, it's typo. It's just stupid typo. Min and max should be mentioned in another order. A result of this typo is that you always print 100%. So if you see the stack progress bar, which doesn't move, then probably there is a mistake like this inside. And this problem is easily detectable in modern world. It's detectable by IntelliJ IDEA, because I wrote the inspection about this. It's detectable by spot bugs, because I also wrote the inspection for spot bugs when I contributed there. And it's detectable by Sonar. I didn't write for Sonar, but other people did this. So you can easily find this problem. But static analysis only works if your boundaries are constant, because to detect the problem, you have to check that 0 is less than 100. If they are like loaded from variables and static analyzer cannot get their values, then it will not tell you. And in this case, AI actually does its best. It does very great explanation what is wrong with this code, and it even fixes it. So it says how to write it correctly. So in this case, AI is very good, and it's actually useful. It's not, once again, like the example I get from my head. It happened at least in Jenkins code base, so you can find a commit which fixes it. And in this case, one setting was completely ignored, and in, like one of boundaries, it was some retention time, and it was used 1 minute always instead of the setting value. So apparently it wasn't tested, and yes, such kind of problem happens. But again, is it a real solution? No, because the code is still confusing. If you look at it, you have to make like mental thinking to think like whether it's wrong or right, and what's actually going on here, what author of this code is going to do. You probably not don't know this kind of algorithm to clump value into the range. So real solution is to use a library method. And if there is no library method, you should write it. That's exactly what I did in Java 21. It was my contribution when I was writing this sample in my book. I decided, hey, why we don't have clamp function in Java? And I produced a pull request, and it was accepted. So since Java 21, you can actually write this way. Clamp %0, 100, and your parameters are named, so it's much harder to mix them. And even if you mix 0 and 100 for some reason, there is an argument check, so you will get an exception because your lower boundary should be less or equal to the upper boundary. So it's much better. And now it's also declarative, like what I'm saying. For every sample, your code should be declarative. You clamp your value to the range. Okay, let's have a few words about strings. Imagine that we want to implement poor man template. Like we don't want to plug some templating library like FreeMarker or Velocity or whatever. We just want to solve some local task, and in this case, probably the good idea is to have a string with some placeholder and replace this placeholder with actual value when you get the actual value and use the result. Why not? It's a good approach. And it works. You can, for example, it's quite flexible, like you can externalize this template string to resources, so you will be able to localize it, to translate to other languages. So it's a good idea. Still, what's the problem with this code?
SQL injection.
Sorry?
If it's an SQL query, then you have SQL injection.
It's not a SQL query, it's just
Performance impact, right?
it's just a text that we are going to print to users. Yes?
Is now?
The problem is that replace all is based on regular expressions, and I think if you supply a user like $2, it tries to replace it with the capturing group number 2, and the capturing group number 2 doesn't exist in the pattern. So it should fail.
That's really good answer. Yes, it's exactly what's the problem. I guess you deserve a book if you really want. Do you want? No.
Yes, I will definitely take it if you offer one.
Yes, you can come later. Yes, because when I did this presentation in other places, people correctly noticed that this is regular expression method, so it accepts a regular expression, but it still looks safe for many people because your pattern is constant and it doesn't have any special characters. It's just user underscore name, so what can go wrong? But indeed you are right that with simple user it works, but if you use something like this, it fails. So when you do replacement, your not only regular expression should be sanitized, but the replacement string should be sanitized as well. So again, yes, you can learn the API and use proper method. But the problem is in API, because we actually have in string class 2 methods, replace, which replaces all substrings, and replace all, which also replaces all substrings, but uses regular expressions. So when you see both methods in your completion pop-up, there is not a big hint from the method name what the method will do, because the suffix O doesn't add any information, both of them doing all replacements. But there is no suffix like regex or something like this. So it's really confusing API. And I guess the problem appeared in Java 1.4 when before we had only replace method, so it was simple, it was great. But in Java 1.4, regular expressions were introduced, and somebody thought that it would be convenient and it would promote a new Java feature if we add convenience methods directly into string. Because you can actually write pattern.compile regex.matcha.replace all, but people will not like it, so why not to do a shortcut? And it's actually a problem, because every time you make a shortcut, you are doing a good job for people who need it, but you are doing a bad job for people who don't need it. Because there are not so many samples in JDK, but I saw this in many third-party libraries, like you press dot and you see completion pop-up, and there are literally hundreds of methods, and you need only one of them, and you have to skip through all the methods you don't need. You have to read the documentation and understand that this is not the thing you want. So remember that convenience comes at a cost. And if you add too many convenient methods, then people will spend much more time learning your API, and likely people will make mistakes like this. There are actually a lot of mistakes when people mix replace and replace all. And it's not always like people don't know those two methods. Sometimes it was just lack of attention because you just selected another option. It looks like something you need and you go on. So be careful when designing your API. And another thing is that it's better to avoid stringly typed code, because the whole idea of Java, like strongly typed, object-oriented, statically typed language, is that for every kind of entity, you should have a corresponding kind of object, and the type system will help you not to make a mistake. Like you will not be able to use this object with something which is not ready to accept such kind of object. So, and we have for regular expressions actually an object which is pattern. So it would be better to use pattern everywhere. But here, for convenience, it was added this overload which accepts string. So your code becomes not strongly typed, but stringly typed. You have strings, and it's very easy to pass the string which means something else. So you are basically undermining all the advantages of static typing system. It would be, in my opinion, it would be better if replace all method accepted pattern as the first argument. And actually many programs will be faster because people are too lazy to precompile patterns. They just use replace all in line, and actually every time you execute it, you compile pattern once again. So if it were replace all pattern and replacement, you would not use this method by mistake. And another short sample, which is quite similar. Imagine that we are working with file names. Well, it's like full file name, like full path, not like just file name, like /etc/password. And we want, for some reason, to count path components. So somebody came up with such kind of code. File name.split file separator, and then we filter empty components, because before leading slash you will have empty component, for example, and we will get 2 if we submit etc password. Why not? So the problem happens on Windows machine because split also accepts regular expression, and in this case, on Unix and Mac, you will have /, which is just a character, but on Windows, you will have \, which is escape character, and something else is expected after that, so you get a problem. There is also naive fix, like you can use explicit compile. Yes.
The file name itself not also contain an escaped separator and have issues with that? If file name has an escaped file separator?
Sorry, escaped file separator?
Yeah, if the file name has like a name like \/ in it.
I think you cannot do file names like this in normal file systems. It's forbidden to have file path separator in file name, even escaped. Okay. So there should not be a problem like this. So let's try to finish. Hopefully it will work. We can again fix naively, but in this case, why not to use API which we already have? Because we should not work with file path as strings. We should work with objects, because file path is actually an object, and there is a class for it, which is called path. So, and there is even a method like this. So you can use it, and well, it works a little bit different. In some corner cases, the result will be different, but it's unclear. Probably it will be even better for your case. But is it actually idiomatic code? And my answer is no, because why you have your file path in string in the first place? You should not have it actually. If you have it in the string, you probably got it from user input, or probably you got it from like deserialized from database or from somewhere, but as soon as you get it, you should convert it to the object, and the rest of your program should work with objects, not with strings. And in this case, you actually don't need this method at all, because you already have path objects. Why not to call getNameCount, and why even writing this kind of silly static method? So yes, use proper types for your entities, and strong typing will help you to avoid bugs. There are several conclusions, but if you want to remember only one thing from my talk, I'd like you to remember this Swiss cheese model and try to use several layers of security in your programs. So hopefully you enjoyed my talk. Sorry for technical problems. Thank you. Yes, please.
Yes, I have a mistake. Too many mistakes. I have a question about string replace all. Why don't IDEA detects that first argument is a const string literal without any regular expressions, and why don't IDEA suggest to use replace in this case? Moreover, I've already found a bug in JetBrains bug tracker, and it's not yet resolved and it's not planned. And I would suggest that during preparing this talk, along with Clamp, you would also implement this one. So is there anything extra about this?
The answer is that it's not implemented because nobody did it. I think that Sonar has this kind of inspection, so it reports if you have a constant string as a regular expression in replace all, because like probably it's not what you want, but it reports it as performance problem. So it's in performance category, like you compile regex, but probably you don't need it. But I was doubting that it's really useful because you are not always have constant string when you have such kind of problem. You may have non-constant string as well, and in this case it will be unclear what you actually want. I guess we report some specific strings, like if you use replace all, dot, or probably pipe, and something else. In this case, it will be definitely not what you want, because if you replace single dot, you will actually replace every character, not dot. So in this case, IDEA reports. Actually, writing an inspection is not just like we will write it and be happy. It's not very much amount of effort, but we should actually check on many projects whether it produces false positives. Probably some people actually want to write such kind of code. Probably we are not aware about this problem. But thank you for reminding. We have a lot of ideas in our backlog. Probably we should prioritize this. I guess there was another question here.
No, not really.
Okay. Yes, please.
How do you convince colleagues to use safe methods like @exact and that? Because often it's said it's too complicated or this will never happen.
Well, in cases where we think that in our project using a particular method is really important, we write a custom inspection. In IntelliJ IDEA, there is a mechanism called structural search, where you can specify a template and say that when you see this kind of template, you should report it, and you can even provide a replacement. So sometimes if you use something which you should not do in our project, like using some, for example, there are some library methods, but in our project you should not use them directly. You should use our own wrappers because we add additional logic. So if you call them directly because you don't know that the wrapper exists, we may highlight it and say better to use that method from our own API. And there is a quick fix. So it's possible to solve this technically. Well, some people may still don't pay attention into this warning. Sometimes it's enforced by quality gates, sometimes not. There are some problems with it, but still there is also code review and so on. So as you can see, there are several layers to avoid this problem slipping into production. Yes?
So most of the example which we saw, and at the end we find the solution is more like a declarative approach, right?
Yes.
And this declarative approach is more closely to the functional programming, right?
In some sense, yes, but I would not say exactly. In general, I think it's more common concept. If you have an idea, if you have an algorithm, you should encapsulate it. So it's mostly about encapsulation. You have clear name for your clear intention. Like you want to do something, just think up a name for this, think up interface, which arguments you need, which return result you need, and then implement it once, test it thoroughly. So if it's implemented once, even if there is a bug, you can find it because you use it from many places, so you test it much more. And if you fix it once for all clients, which is, of course, more convenient.
But again, I guess this idea is more about change the mindset, right?
Yes, exactly.
And
don't try to do everything manually.
Exactly. And this is what functional programming teaches. Like when I started with the Java, then I switched to the Scala, and when I did some functional programming, and I realized the way I was writing a code in a Java is completely different. And now I switched back to Java, and the way I'm writing, there's a more declarative way. Like it is completely different, like a less, but it's still difficult to teach others how they can.
Yes, but I would say, but in modern Java, it's quite possible and quite comfortable to write in more declarative and in more functional way, of course. Of course, we are not so functional as Scala, but still Java is doing many steps forward in this direction.
But anyway, like, do you want to share some tips? How can we push our teams to go in this direction?
Well, I don't know your team, so I have no idea. In some cases, with some people, just saying it's better to do this will help. I don't know why it doesn't help with your team, so sorry, I cannot give any advice. Yes, please.
During your presentation for every tasks example, you try to find a fix using AI. Do you think AI is the best, the most useful now tool to avoid bugs?
I think that we are only at the beginning of this AI revolution or something like this, and we don't know yet how to use it efficiently. So what I have shown in my presentation is very inefficient way. Like you should either suspect that there is a problem in this method, or you should just check with AI every single method in your program, and it will output you a blob of advices, and you should read through them. You will get quickly tired. So it's, of course, inefficient way, but probably the tools will become better, probably like in very short future. Probably the analysis will be done in background, and AI will constantly monitor your code and will give you advices only when it thinks that it's really important to draw your attention to some specific thing. Now I'm not aware that such kind of convenient tools exist, but I think they will appear in quite near future.
I think the answer to this question should be this. You have already a slide with the Swiss layers of Swiss cheese.
Yes.
So there is no silver one bullet.
AI could be one more layer. Any more questions? Yes, please.
So you mentioned quality gates and custom inspections.
Yes.
And in one of your previous talks, you said that IntelliJ IDEA code base has 6 failures for inspections that should never happen. Had this number go down since that? It was like a year ago.
I think it was about like our profile of inspections which we try to keep at 0. So we call it like zero tolerance inspections. Yes, we have such kind of profile. Right now, I guess it reports more problems, like probably 20 problems, but we added a lot of inspections there, and at some point we were not catching up. Like our infrastructure teams or our core teams were adding more inspections, more project-specific inspections, not like general Java inspections, but project-specific, like we should do proper threading or something, and fixing such problems require sometimes quite understanding of code and sometimes quite refactoring, so it's not like one-line fix. And sometimes, they were adding inspections faster than people can fix it. But now we have, quite recently, this zero tolerance profile was actually added as a quality gate. So before it was like post-commit check, which was done several times a day, and we were just monitoring it. Now it's actually pre-commit check, so there were technical problems, mostly with like performance, amount of agents on our CI server and something. Those problems are solved, so now it's pre-commit checks, and I hope that we will actually go to zero. So at least new problems should not appear now. Or well, they can appear if we change configuration, like add new inspection to the profile or something like this, because problems may appear in old code, but people will not be able to commit new code that contains problems. So things will be definitely better. I guess here, yes.
Yeah, one question. One very tricky category of bugs are bugs related to, for example, the memory model and concurrency, or more specifically where people don't expect concurrency or don't take care of it. Do you have any checks regarding that, or is it too difficult?
Yes, for static analysis, doing concurrency checks is quite difficult. We have some concurrency checks, but they are pretty simple ones. So one check which can be done by static analyzer quite good is, for example, if you use the same variable in synchronized and unsynchronized context. So if you use it sometimes under the lock, sometimes not under the lock, probably you have problems. Not always, but probably. So we report such problems. Or sometimes something very trivial, like you declare a volatile variable and you increment it. So likely you are doing something wrong, because this increment will not be atomical. But complex problems with concurrency cannot be solved by static analyzer. At least I'm not aware about good static analyzers that can do it. There are some classes of problems which can be solved by dynamic analysis. I especially like the tool which named, I guess, DL check, which is short for deadlock check. You can, I guess, find it on GitHub. It finds a special class of problems where you have potential deadlocks. Like if you take log A then log B in one thread, and in another thread you take the same logs in opposite order, you will have deadlock only if the time coincide. But this tool will report this situation even if time don't coincide. So you don't have deadlock, but it's a potential deadlock. It's a very serious case because deadlock may happen anytime if you have different timing. So this tool reports it, and you can simply like run your test suite or run your software instrumented, and you will get a lot of output from this tool. You can analyze it and find bugs like this. So in some cases, dynamic analysis helps. I've heard also about Pathfinder, but I haven't actually tried it much. And there are also other tools more advanced like lean check to test whether concurrent algorithms could be linearized. So there is a whole theory behind it. But in general, yes, concurrency bugs are very hard, and there are not so many good tools to catch like many of them. So, no more questions? Then thank you again. And